Hello, this is going to be Lab 5 for Physics 2212. In this lab, we are going to be looking at Faraday's law, and we are going to be trying to understand it using the data that we collect in the Lab 5 experiment, which involves magnets going down aluminum tubes, which are going to be representing normal metal tubes since we don't have those. The fundamental equations that we are going to be using is Faraday's law, Bloch-Swavet's law, and then Newton's second and Newton's third law. So for this lab, what we're doing is we are taking an aluminum tube and we are going to be using that to represent a metal tube, and you are going to drop a magnet down one end of the tube and you're going to record how long it stays in the tube. And what you're trying to figure out is how Faraday's law or how it is being used in this example, because when a magnet falls down a cylinder, which is basically a stack of rings, okay, the magnetic field is going to interact with those rings and it's going to strengthen as it gets closer to the rings, and so due to this is going to affect the magnetic flow as it interacts with those rings, and typically the magnetic force is going to be pointing upward as it goes down the tube, and this is going to affect the magnet's velocity slightly. And so here we have the glow script model, where we were looking at the tube's width and radius and like how those are different, because the width is representing the actual like aluminum part of the tube, whereas the radius is the inside. And so then we have our data where we are representing the bar magnets and making the tube and graph function. And then this is calculating the magnetic force and how it's being affected as it goes down the tube and the velocity. And so looking at this, we get this graph and this velocity, and the graph did not turn out how it was supposed to, and the time in the tube didn't either, because it said that the time in the tube based on the calculations is 0.3332 seconds, and that's obviously incorrect. Based off our average time in the tube from the previous parts of the example, it should have been somewhere in like the 2-second range, but it was not. So some errors that could have occurred that made it this way could have been errors in the glow script model. I double checked it and I didn't think that there was errors, but I quite possibly could have had errors in it or not representing the function correctly. If there was outside influences when doing this problem, it could have been having metal around in our environment that was not to tube, or having errors when making my measurements. However, you do see, looking at the graph, you kind of see a visual of how the velocity is changing as the magnet is moving downwards through the tube, and the velocity would be changing in a normal example too. So that is correct. So if the resistivity of the conductor is decreased, then the current is going to increase inside of the conductor, and the magnetic force is going to increase. And due to this, the time that it takes the magnet to fall down the tube is also going to increase. and if holes or slots were cut into the tube, it would affect the model as there would be a lower magnetic interference because there would be less rings that would be interacting with it, and due to that the magnet would fall quicker down the tube because the magnetic field is being interacted with less.